Standard 13, we're moving on from the stuff that you know from geometry to some new things for you, a few new terms. The first one is not new, though. I think you guys know what an angle is. So I'm going to write the actual definition. When two rays share an endpoint. Two rays. You guys remember from geometry what a ray is?
Yeah.
Yeah. And the bit. So if I have a ray going this way, and then from that same endpoint another ray, that has created an angle. Okay. Yeah, I think you guys know what an angle is. All right, the initial side of your angle, it is where the angle begins. So if the initial side is where it begins, what do you think the terminal side is?
Where it ends.
No. The angle ends.
Shit.
All right, guys, so positive and negative angles, that all has to do with the direction that you travel to get to your terminal side. So I'm going to draw my initial side. For you guys, it's always going to be on the positive x-axis. So that is the initial side. Then I'm going to put the terminal side over here. If I have traveled counterclockwise, so if I've gone that direction, that is a positive angle. We'll say that's 120 degrees. Counterclockwise. Does that make sense what I mean by travel? Like going from your initial side to the terminal side?
Yeah.
Counterclockwise?
So you only, that's the initial side because you're going counterclockwise. Right?
So when we fill in standard position right here, that means the initial side is always on the positive x-axis. So that is always where your initial side will be. So if for a positive angle we travel counterclockwise, what direction do you think we go for a negative angle?
Clockwise.
Clockwise, good. So we'll do one of those over here. So there's my initial side again. Terminal side. I'm going this direction. That's negative 120 degrees.
What about like if it goes past x-axis?
Yeah, you can do that. So,
Which is negative?
like if you had, like if there's your terminal, I'm sorry, your initial, and there's your terminal side. If you're going this direction, that's, let's say, negative 200 degrees. Okay, what would it be in the positive direction. Good. That's going to matter later. Okay. But yes, so as long as you're going that direction, it stays negative no matter how far around you go. Okay. Are we okay with the positive and negative? Okay. Next definition is for a quadrantal angle. I'm guessing you don't know that one. All this is the terminal side is on an axis. So if the terminal side ends up on the X or Y axis somewhere, that's a quadrantal angle. Creates a quadrant, yes.
That makes sense.
It's good. All right, so now we're going to draw a few angles. So go ahead and draw on your little X and Y lines there. But back to this, I just want to make sure we know a couple of things. Can you guys name the quadrants?
1, 2, 3, 4.
Like a C.
I.
That's almost an I. Let's make that better. Okay. And so this starts as 0 degrees. Where is the positive y-axis? Like how many degrees is that? 90. Over here would be on the left 180. What about down at the bottom? And if you go all the way around a circle? Okay. Just making sure we understand how the degrees break down. Okay, so let's look at these sketches. The first one's 55 degrees. So what quadrant will 55 degrees end up in? 1. First quadrant. Okay. So my initial side is always on the positive x-axis. Then from there, I have to go somewhere in the first quadrant. 55, that's a little more than halfway, right? Okay, that's what I'm looking for. I'm not going to be picky and say, oh, you graphed, 58 degrees instead of 55 degrees. I don't care. Okay, not looking for perfect, just looking for approximately the right angle. And then draw your little arrow so we know, hey, that's the positive angle that I'm talking about. Okay with the first one? All right, I want you guys to try to graph 3 and 4 for me. Run away. Once you sketch them, check with your neighbor, make sure you guys agree.
What did you validate this? I think you validated one. I think maybe not.
Let's go.
It's all right.
Okay.
Is this just like the circle?
So where? And that one is that one.
Is that right here or what? Somebody back. Did one of your back here to the dance party?
What?
Did they have a dance party? There's a video of people dancing.
That was during second period.
I saw why they couldn't afford to use dance.
No, that was at the end. It's 90 for her quadrant, which makes sense, right? It's like right angle. Was it like here?
Yeah. Doesn't matter.
Yeah, like, yeah.
Those silly.
All right, Chris. Let's look at these. So negative 180. So there's my initial side, right? Where's the terminal side? That's the other way, right? Oh, maybe. It's over there, okay? To show that it's negative 180 and not positive 180, make sure you put your little arrow in that it's going negative, okay? Don't forget your arrows. And is that in a quadrant? No. That is a quadrantal angle, yes. So, and when we're picking the quadrant it ends up in, guys, that's always where the terminal side ends. Like where the quadrant that lies in is the quadrant that your angle is in, okay? All right, so 280, initial side. Where is 280? Which quadrant? Fourth, like just a little bit into the fourth, right? So, I don't know. That's probably too far, but that's okay. So, there we go. And fourth quadrant. Okay. All right, 425. That's more than 360, right? How much more than 360? 65. So what quadrant is that going to be in?
Would you write 425 or you write 65?
So you're going to show it as being 425 by going like that. Yeah, it's a little spiral going on there. Okay. We're going to get into what are called coterminal angles, and that's 65 and 425 are coterminal. Okay. All right. Any questions with sketching the angle? It's not bad, right? Okay. Definition of 1 radian. Okay. Let me write it out first, and then we'll talk about what it means. You can cross out, memorize this. I'm not going to ask you to regurgitate it, but I do want you to understand what it means. Okay, the measure. Izzy, you ready? Okay. The central angle whose intercepted arc is equal in length to the radius. Again, write it down and I promise I'll explain. Arc. intercepted arc. You gonna make it round? Okay, I'm gonna make a bigger one of these circles just so I can show you what's going on. All right, so let's talk about some of these words. Measure of the central angle. What is a central angle? Anybody know? An angle in the center. Pretty much. So if you have a circle, it's an angle whose vertex is in the center of the circle. Okay, that's a central angle. All right, then it says the intercepted arc. What is an intercepted arc?
Is it like arc in between the two?
Yes. Earlier someone said, well, it's the arc that's intercepted. Okay, yes, but that doesn't really take us where we're going. It's this piece right here. That part of the circle is the intercepted arc. And do we all know what a radius is?
Yes.
Yes, good. Okay, so let's look at what this is talking about. So you guys are very comfortable measuring angles in degrees, right? Like if I say 90 degrees, you know what that is talking about. Okay, radians are just another way to measure angles. So if you did feet and inches, right? That's just a conversion between the two. So radians and degrees, you can just convert back and forth between both of those. Okay? So what it is, I'm going to start by drawing on here. Red. There's the radius of my circle, right? Do you guys agree that that has a length? Like we could measure that and you could tell me this is how many inches or centimeters or whatever. Okay. Could I then take that length, and I know it's curved, but could I travel the same distance on the circle?
Yes.
Okay, does that make sense to you? So that's what I'm talking about, is that distance. I'm now going around the circle. It's curved, so I'm not going to be exact here. Does that look pretty close to the same distance? Close.
No.
A little more? A little more. Remember, it's curved. Okay. I'm then going to connect that and make an angle. Do you see the central angle that was created?
Yes.
Okay. The measure of that angle, so in here is 1 radian. Okay, because the length of this arc is the same as the length of the radius. Okay. If I continued marking those off around the circle, so there's 1 radian. If I did it again, there's maybe 2 radians, 3, and then a little to get back to the x-axis. Okay, we know it's 180 degrees. What number is 3 and a little, though? You guys know a number that's like a little more than 3? Pi, yeah, so this is pi radians. So 180 degrees is equivalent to pi if we're looking at radians. Right now, you definitely like degrees more, but by the end of trig, you will absolutely like radians better than degrees. Okay. So if I kept going and got all the way around to 360 degrees, how many radians do you think it is to go all the way around the circle? 2 pi, yeah. Okay. 2 pi radians. All right. So you don't have to memorize this. You don't have to like spit it back to me. But I just wanted you to have some understanding of where radian comes from and why 180 degrees is the same as pi in terms of measuring things. So we're going to use that if you turn the page. We're actually going to jump down into the middle of the page here for number 7. No calculator for this. All right, so we're going to convert from degrees to radians. So I tell you here, you're going to multiply by pi over 180. That's your conversion factor. Pi over 180 is just a special way to write 1, okay, because they're equivalent to each other. If you think about what you're doing, if I multiply by pi over 180 degrees, you guys see how the degrees are essentially going to cancel out? Okay, because you're turning it into radians. You don't want degrees anymore. Then all you have to do is reduce your fraction. So what will I end up with here? What can I divide 70 and 180 by? 10. So I get 7 pi over 18. And that's it. Okay, let's do one more together. So 210. I'm going to multiply by pi over 180. All right, so again, what can I divide 210 and 180 by? 10. Start there. So I have 21 pi over 18. And now what can I divide by? 3. So I get 7 pi over 6. You certainly could have divided by 30 in the first step. But if you don't see the biggest thing to divide by, that's fine. Just keep reducing until you can't anymore. All right, so try C and D for me. Check with your neighbor. What could you divide 566 and 180 by? Okay. Start. 2. Yeah. Okay. I mean, I teach it here this year.
I watched your videos. So you please. I was just asking like that. But on the data they're not so try to get that.
You'll be very good, I would think, for the free response. I would make sure you use it. We know the choices just because they're very specific.
So like the multiple choice can be on.
Yeah. So keep this.
Alright.
Are we going to start converting? Okay. All right, guys, so negative 190. What'd you end up with?
Negative 5 over
Good. Negative 19 pi over 18. Okay. Negative 566. So you can divide it by 2, right? And we get to negative 283 pi over 90. Do you guys know the shortcut to check to see if a number is divisible by 3? Yeah? No?
Yes.
Well, yes, you could just divide by 3, or look at the digits. What's 2 plus 8 plus 3? 13. Is 13 divisible by 3? No, so then 283 is not divisible by 3 either.
That always works.
For 3s, yeah. So if it was 285, that would be divisible by 3. Okay.
I know that.
Yeah, I know.
I don't know why.
People have not been telling you the tricks. All right, but that's all that you can divide by. That's the answer. Okay? We good? All right, next section. So now we're going to convert the other way. So I give you the angle in radians, and I want you to turn it into degrees. So you're going to multiply by 180 over pi. You want the pi's to cancel out in this case, and you want to end up in degrees. So you should have a degree in your numerator. So pi's are gone. And then how many times does 6 go into 180? 30. So this is 30 degrees. Okay. Let's do another one together because I want to make sure you don't do this the long way.
Wait.
Don't do 180 times 7.
Wouldn't it
So
be
hold on.
pi squared equals 180 times 6?
Okay, we're converting now from radians to degrees. So we multiply not by pi over 180, but by 180 over pi. So when you multiply, no fractions, you just multiply straight across. You can cancel out anything in the numerator with anything, any factor in the numerator with any factor in the denominator.
Sorry.
The only time you cross multiply is if it's like 2/3 equals 4/5. If there's an equal sign in between, then you cross multiply. Okay. All right. On this one, yeah, don't do 7 times 180. I don't want to do 7 times 180. So I would divide first. How many times does 5 go into 180? 36. Okay. And the pi's cancel. So 7 times 36, I do that in parts. That's the same as 7 times 30 plus 7 times 6. So what is 7 times 30?
22, 210.
210. And what's 7 times 6? 42. What's 210 plus 42? There you go. Okay. All right, try C and D. I mean, essentially, yes, like that's where everything else comes Okay, so
These two are like,
Oh, it's 36. Yeah. All right, guys, let's look. All right, so times 180 over pi. Pi's cancel. How many times does 3 go into 180? 60. And then 5 times 60. Are you guys okay? Negative 300? You're fading on me, guys. Come on. We're almost to the end. Okay. All right, last one then, times 180 over pi. Cancel pi. How many times does 6 go into 180? Too many. No, 30. Okay. What's negative 13 times 30? Close. Negative 390. Okay. Make sure you're putting the degree symbol when your answer is in degrees. There's not a radian symbol. Like pi doesn't mean radians. It's just what you usually use when you're talking about radians. All right, questions on converting. Back to the top, we got to talk about coterminal angles. We're almost done. All right, coterminal angles. Two angles with the same initial and terminal sides but different measures. All right, so let's look back at our first page here somewhere. Okay. All right, let's just make one. So guys, let's think about it. If I do an angle, we'll go back to 120 degrees right there. What is the negative angle that's the same initial and terminal side? How could I label this if I'm going this direction? What would it be? Go ahead, Peter. Negative 240, yeah. Okay, how are we figuring that out? Mental math, okay, but what number are you, like, referencing? Yeah, there's 360 degrees in the circle, right? So if you want to find coterminal angles, all you have to do is add or subtract 360 degrees from your given angle. Or what radian is the same as 360? 2 pi. So or add or subtract 2 pi. Okay? So I'm going to give you an angle and I'm going to say find another angle coterminal to it. Let's go try that down here. Back down to the bottom of your page, number 9. We're going to do C and D first. We'll start in degrees. All right, so 390. Would you like to add 360 to that or subtract 360 from that? Okay, so what is 390 minus 360? Okay, there's your coterminal angle, 30 degrees. Sometimes, just make sure you read the directions. I might ask you for 2 coterminal angles. I might ask you for a positive and a negative coterminal angle. So letter D, do you want to add or subtract? Add, all right. What's negative 80 plus 360? 280, right? 280 degrees. There's actually an infinite number of answers to this because you could just keep adding 360. Don't be the kid who just adds 360 like 15 times just to be funny, okay? Don't mess it up. So that's all you're doing. You're just adding or subtracting 360, okay? Pretty easy with degrees. Okay, so with radians, no, you are not going to convert the radian to degrees so that you can add or subtract 360 and then convert it back to radians, okay? Just add or subtract 2 pi. So how do I add or subtract fractions? Common denominator. What's the common denominator going to be? 3. So this is really pi over 3 plus or minus. Yeah, are we okay with that? 6 pi over 3? So if I add, what's 1 pi plus 6 pi? All right, so 7 pi over 3. If I subtracted, what would I get? Yep, negative 5 pi over 3. Does that make sense? Okay. All right, so same thing with negative 2 pi over 5. You're adding or subtracting 2 pi. What's your common denominator? 5. So what does 2 pi become? 10 pi over 5, right? So when I add, what do I get? Negative 2 plus 10. I know you can do it, guys. 8. All right, 8 pi over 5. What if I subtract? Good. Okay. So if the original angle is given to you in radians, your answers need to be in radians. Okay. Questions on anything? Game. Okay. Game. Sure. Do you guys want to do shooting game, bluffing game? We clearly can't do castle game again in this class for a while.